Hello viewers, today we are going to discuss about mesh analysis. In the given circuit, you need to find out the current flowing through a 5 ohm resistor. So that is IL using mesh analysis. Okay, what is the first step in mesh analysis? The first step, you have to name the circuit. So A, B, C, D. First step, you have to name the circuit. Second step, assume the current in individual closed path. So here there are three closed path: first closed path, second closed path, and third closed path. Say the current is I1 and the second loop current is I2 and the third loop current I3. So here all the currents are flowing in clockwise direction. You can assume your own current direction. The current may be clockwise or counterclockwise. Here I am assuming all the currents are flowing in clockwise direction. So what is the next step? The next step, you have to apply KVL for individual closed path or mesh. Then in loop 1 or in mesh 1. So where is your mesh 1? A, B, D, A. Apply KVL. So what is KVL? In a closed circuit, sum of potential drop equal to sum of potential rise. So this is our KVL. So A to B, we have 3 ohm resistor. The current flowing through 3 ohm resistor is I1 and I3. Both the currents are flowing through 3 ohm resistor, but the direction of I1 and I3 are opposite to each other. So the drop is V equal to I into R. So your resistance is 3 ohm. Current, resistance into current. There are two currents. So both are flowing in opposite direction. So I1 minus I3. At present we are writing the KVL for loop 1. So give the importance to first preference to loop 1 current. So I1 minus I3 is correct. Plus B to D, 5 ohm resistor. 5 ohm resistor is common to loop 1 and loop 2. So I1 current and I2 current are flowing through 5 ohm resistor. Your I1 current is flowing in downward direction. Your I2 current is flowing in upward direction. So I1 minus I2. So the drop is 5 into I1 minus I2. Similarly, D to A. From D to A, we have 1 ohm resistor. The current flowing through 1 ohm resistor is I1. So plus 1 into I1. Again, we have one more element, that is our voltage source. Now look at the current direction. A to B, B to D, then D to A. Current is flowing from D to A. So the current is flowing from negative to positive. D to A means negative to positive. So negative mean low potential, positive mean high potential. If the current is flowing from negative to low potential to high potential mean it is potential rise. So equal to 8. Solve the equation. 3I1 plus 5I1 plus I1. So 9I1 minus 5I2 minus 3I3 equal to 8. This is our first equation. Similarly, in loop 2 or in mesh 2. In mesh 2, B, C, D, B. Apply KVL. We are assuming the current in clockwise. So travel the loop in clockwise. B, C, D, B. Not B, D, C, B. Okay. So apply KVL. Sum of potential drop equal to sum of potential rise. B to C. 3 into 3 ohm resistor is common to loop 3 and loop 2. So 3 into I2 minus I3. Because I2 and I3 are flowing opposite to each other. So I2 minus I3. Next, C to D, 1 ohm resistor, current is I2. So plus 1 into I2 Next, and one more element, 6 volt battery or voltage source, C2D means the current first meeting the positive terminal, second it meets the negative terminal. So current is flowing from positive to negative. Positive means higher potential, negative means lower potential. If the current is flowing from higher potential to lower potential mean it is considered as potential drop. So you should write 6 volt under the potential drop. Next, D to B, the resistance is 5 ohm. The current flowing through 5 ohm is I2 and I1, both are flowing in opposite direction, so plus 5. So here you have to write I2 minus I1. Why I2 minus I1 means we are writing the KVL for second loop, so give the first preference to second loop current. So second loop current minus other loop current, that is first loop current. So 5 into I2 minus I1 equal to 0. Just solve the equation. Minus 5 I1, 3I2, 4I2 plus 5I2, you will get 9I2 minus 3I3 equal to 0. So this is our second equation. Similarly, in loop 3 means A, C, B, A. So in mesh 3, A, C, B, A, apply KVL. So for our convenient, I am writing here A, C, B, A, apply KVL. So sum of potential drop equal to sum of potential rise. So A to C means the current is flowing from negative to positive. Negative to positive means it is potential rise. So for 3 ohm resistor is there, so 3 into I3 is the drop, so 3 into I3. Next, C to B, now 3 ohm resistor, the current flowing through 3 ohm is I3 and I2, both are flowing in opposite direction, so plus 3 into I3 minus I2 plus, again we have B to A, 3 ohm resistor, so 3 into I3 minus I1. Just solve the equation, you will get minus 3I1 and minus 3I2, 3I3, 3I3 plus 9I3 equal to 4. Equation number 3. Now write all the 3 equation in matrix form. We will strike out this. Your first equation, 9 minus 5 minus 3. So 9 minus 5 minus 3, and the unknowns are I1, I2, I3, 8. Second equation, minus 5 9 minus 3, minus 5 9 minus 3, 0. It is not 0, so this plus 6 will become minus 6. So here it is minus 6. The third equation, minus 3 9 and 4. By Cramer's rule, I1 equal to del I1 by del. Similarly, I2 equal to del I2 by del. We need IL current. So I1 and I2 values are sufficient to find the IL current. If you want I3, similarly I3 equal to del I3 by del, you will get the I3 value. Just solve the equations, you will find your I1 will be 1.67 ampere, your I2 will be 0.67 ampere, we need IL equal to I1 minus I2. So 1.67 minus 0.67, you will get 1 ampere. So this is our IL. So in the given problem, your IL equal to 1 ampere. So like this, you need to solve your circuit using mesh analysis. Thank you.